So once you've got that, we have a data frame. We can start accessing rows and columns. So let's just walk through some of these simple pandas things that we can do with it. So we have, I'm going to create a data frame here with 1, 2, 3 rows, and each row has 4 elements, and R1, 0, 0, 0, 1, 0, 2. You can see these are just the locational places, 1, 0, 1, 1, 1, 2, and 2, 0, 2, 1, 2, 2, and R1, R2, and R3 are the row numbers that we are giving it. So, and we give the columns are row labels. So R1, R2, and R3 correspond to the column row labels, and the rest are A, B, C, just like before. So let's run this and print it another way. So we do this here. We print, look at the way the data frame is. So the data frame is sitting in this particular location. And now what I want to do is I want to set the index of this data frame as R1, R2, and R3. So I tell it here, I call the function on data frame, I call the function set index, and I tell it that the index corresponds to the column that is named row label. So this row label came from here. Okay, and I'm saying in place equals true, which means don't create a new data frame. Change this data frame so that it has the same, it's the same data frame, but it now has been reformatted so that the rows have been taken out, row labels have been taken out of the data frame and put into the index instead. So that's what this becomes like. Just to be clear on this, what if I did print df here? Then you notice what I'm getting here is the row label is another column in it, right? And ABC is over there, right? So it's yeah. Okay, so these are our columns. But rather than getting, you know what? Let me just try this separately. It'll be much clearer if I take this out. Control C. So here, so we can see the row label is just another column. So when I make it into an index, it becomes an index that is no longer a column. It's no longer, we can no longer refer to it by its column name. Okay, so it becomes a row label, just becomes an index for that table itself. So that's really the difference there, but it's the same table. If I say in place equals false, then it's going to create a new data frame. My original data frame will not be, for example, if I did this, then notice my data frame is unchanged, right? My data frame is unchanged because I've created a new data frame. I could call this x equals this and do print x. And you see x has row label as a separate index, but df is unchanged. So the in place equals true is kind of helpful if you don't want to create a new data frame, which is probably advisable. I mean, if you have a data frame that contains, say, 3 or 4 gigabytes of data, you don't want to create another data frame that contains 3 or 4 gigabytes of data, right? Or maybe 100 gigabytes of data. It's going to just use up memory for no reason at all. So in place may be not a bad idea, right? So given that we have this data frame here now, right? Let me get back to this. Is equals true, run that. So this is the data frame we are working with right now. So the data frame now has 3 columns, A, B, C, and rows that are indexed by R1, R2, and R3. So let's see how we can get data from this. Well, the nice thing is that you can access a column directly by just using this dictionary method of accessing data, because the way Pandas works is the columns are just dictionary elements, right, that are indexed by the name of the column. So I give the df is my data frame, b is the column name, I say dfb, and I get the data that corresponds to that column. And note that it comes with the index. So I have R1, R2, and R3. This is now a data series, right? And if I do type of this, it says a pandas core series.series. So it's a data series. And if I did type of df, it's a pandas core frame data frame. Okay, that's the idea here. So let me go back to this and do df b. To get row data, I use this attribute called location and use the index, because the rows are also indexed by, they're like dictionaries indexed by the row index value. So I want to say df.loc R1 is going to give me the row that corresponds to R1. So it says column A has a value 0, column B has a column 1, column C has a value 2, and this is another data series object, right? A data pandas data series. I can also get rows by row number, because this is kind of useful because sometimes it's faster to get by row number rather than by indexing. If you're looking at time series data, for example, you know they're arranged by row number, so you can just use the number rather than having to use the date or whatever every time, right? So if I do this, then give me for ilog 0, which is, use the function ilog, which is indexed by integer rather than this, and this is going to be the same thing as if I had, let's say for 1, for example, the same values that I have for B, right? So it's the the rows, not the columns. So this is the same values as R2. So oops. Yeah, so this is the same values as here. I apologize for that. You got a little bit confused there. Because we are getting ilog, we're getting the rows here. So this corresponds to this. This is the same result. You can get multiple columns from the table. So all you need to do is you give a list of column headers and you get multiple columns there. So note that this is a list. So it's not like df, b, and a separately, but inside a list here. So this gives me this like this. If I tried doing something like this, and this is a common mistake, so watch out for it. dfb we know works, but if I did dfb comma a, then that's not going to work, right? Because there's no key that corresponds to that. So this has to be in the form of a list. Okay, so just watch out. This is a very common mistake in working with pandas data frames. You can go and get a specific cell from the data frame. You can, to do that, you want to use the lock function, and in the lock attribute rather, you tell it which index you want to use and which column you want to get data from. So you can do that, and this will give us the item in here, which is saying R2 is the index, so it gets this row, and B is the column, you get that one. You can try what's called chained indexing, and if I do this, this will give me the same result. Let me make that B as 1, 1, but there's a slight difference in that, and we will see briefly very soon. We'll see what the difference with that thing is. You can slice your you can slice your data frame just like we did with the NumPy array, and the goal here is the basic procedure here is very similar to, because remember it's underlying it there's NumPy anyway, so you can slice by the rows by giving the row colon row thing here. So we use df.lock, and we say we want row from R1 to R2, so we get these two rows, and we get 0, 0, 0, 1. We don't get row 3. Or you can choose a row column combination, and that would be, in this case, we want R1 to R2 and B and C, so we get that little sub matrix here 0, 1, 0, 2, 1, 1, 1, 2. So next we're going to look at this is the basics of pandas. So the idea here, just to recap a little bit, that what we are doing is we create a data frame, and from the data frame we have multiple ways of accessing data from it. You can access columns by just giving the column name and using the dictionary structure by saying dfba, for example, inside a list will give you a subset of columns for that data frame, or if you say dfb, that gives you the one single column. And you can use the lock function to either get a single row or as a slicer to get multiple rows like here, or you can use it to drill down into a single column, a single data point, by giving both the row as well as the row index as well as the column name, and you get that thing. And again, you can take a slice also that contains a slice of rows or a slice of columns. So that's the basic structure. What we're going to do next in the next unit for this class is we're going to look at how to get data from various sources, and then do some basic manipulation with pandas before we move on to next week's more analytical approaches with pandas itself.